Let's take a moment to talk about a special kind of ratio called a rate. Now I'm going to start by giving you an example of a rate, and then we'll talk about what exactly it is that makes this a rate. Let's say that we know that Allie jogs 9 miles every 2 hours. We can certainly describe that as a ratio, 9 miles to 2 hours, or in fraction notation, 9 miles per 2 hours. What is it about this ratio that makes it a rate? Well, there's a suggestion here that if we change the number of miles that Allie jogs, the amount of time that she'll take will automatically change. If we change the amount of time that Allie jogs, the amount of distance she jogs will automatically change. Right, there's a suggestion of cause and effect here. By finding out how much time she jogs for, we can always figure out how far we went. This is describing a property of Allie's jogging. Compare that to this story. Suppose I told you that a class had 30 students, 12 girls and 18 boys. So the ratio of girls to boys in the class is 2 girls for every 3 boys. Now this describes something about the makeup of the class. And if I took groups out of this class, I would expect their makeup to be about the same. But if someone told you a story like this, and then said that they were adding 3 more boys to the class, would you expect 2 more girls to automatically appear in the class? No, of course not. You'd expect the ratio to change instead. So this would not be a rate. If we change one quantity, we do not expect the other quantity to change automatically. Now the main point of introducing this notion of a rate is when we have a rate, it makes sense to compute what's called a unit rate. What is a unit rate? The unit rate describes how much the first quantity changes when the second quantity changes by 1. Let's see an example, just to see what we mean here. Suppose we know that Allie jogs 9 miles every 2 hours, and we want to know what is the unit rate. That is, how far will Allie jog if she jogs for 1 hour? Now, why did I choose 1 hour? Notice the time is the second quantity. The distance is the first quantity. So we're asking, when the second quantity, the time, changes by 1 hour, what will the first quantity, the distance, change by? Now it might occur to us to use a proportion to solve this problem. It might occur to us to say 9 miles over 2 hours equals X miles over 1 hour. But you know what? Looking at this, you know what I see? I see that I'm dividing my X by 1. So instead of bothering with this and thinking about this as a proportion, I'm going to say, I don't need to work this hard. This is X. What will the units of measure be? Miles per hour. I'm going to think of my unit rate as just a number, because it's always over 1. The unit rate is just a number, not a ratio. The 1 is implied, which means how will we figure out the unit rate? Well, we'll just do this division. 9 divided by 2. We could just say 9 halves, but probably a mixed number is going to be more helpful. 2 goes into 9 4 times, with 1 left over. So this is 4.5. The unit rate is 4.5 miles per hour. There are 2 more terms involved in rates, 2 special kinds of unit rates. We have what's called a unit price when the first quantity is an amount of money. So for example, suppose I told you that candy bars are on sale, 5 for $2, and I ask you to find the unit price. In a unit price, the first quantity is always the amount of money. The $2 is the amount of money. So the ratio that we're interested in here is $2 over 5 bars. And when we do this division, we'll get some number of dollars per bar. Let's do this division. 5 into 2. Do we like to express money as fractions? No, we like to express money as decimals, don't we? So let's see. Decimal point in 2 just comes at the end. Decimal point in my answer goes up here. 5 goes into 2 0 times. I add in a trailing 0. 5 goes into 20 4 times. $0.4. Do we normally say $0.4? No, right? We always put in one more digit. Normally we would write this as $0.40 per bar, or 40 cents per bar. So the other thing to keep in mind about a unit price is always give 2 decimal places and round if you need to. Right, this applies if you're working in American currency or any currency that's 100 little units to the big unit. A unit rate is a speed if the second quantity is time. The question might say, what is the speed? But it might also just say, how fast? So for example, suppose we're told that Jim types 500 words in 15 minutes, and we want to know how fast he types. Again, this phrase, how fast, tells us that we're looking for a speed. So no matter what order they're set in, we want to take 15 minutes to be the second quantity. So we'll have 500 words over 15 minutes. Going to be some number, first unit, words per minute. And in order to find out how many, we'll do this division. So denominator into numerator. 15 goes into 5, no. Into 50, I think 3 times, right? 15, 4, 15 goes into 50 3 times again. So we get 33 and 5/15. We'd like to put that in lowest terms because the instructions tell us to. I think these have a common factor of 5, right? We've got 5 times 1 over 5 times 3. So my fraction part will simplify down to 1/3. 33 and 1/3 words per minute is how fast Jim types. All right, let me give you some examples to try. The first one is just the simple unit rate. Suppose we know that Judy grows 1,345 bushels of wheat on 25 acres of land, and would like to find the unit rate. Pause the video and try this now. Okay, this isn't a special kind of unit rate, so it's just going to be first quantity per second quantity. So 1,345 bushels on 25 acres is going to be some number of bushels per acre. How many? Well, we need to do division to find out. 25 acres into 1,345 bushels. Right? As always, numerator divided by denominator. 25 goes into 1? No. Into 13? No. Into 134? At least once. I think 5 times, right? 25 times 5. 5 times 5 is 25. 5 times 2 is 10. Plus 2 is 12. Yeah, that's it. We'll subtract. 25 goes into 95 3 times. 3 times 25 is 75. 20 left over. Now I could stop and give my answer as a mixed number, but I think I'm going to go ahead and answer as a decimal, right? The decimal point in 1,345 is right here. Copy it up here. And now that I have a decimal point, I can add in a 0. 25 goes into 200, I think 8 times. 8 times 2 is 16, 17, 18, 19, 20. Yeah, exactly 8. So nothing left. I've got 53.8 bushels per acre. If you chose to answer as a fraction, you should have gotten 53 4/5 bushels per acre. Okay, now I'm going to ask you to find a unit price. Suppose that Alex pays $3.99 for a 3-pound bag of apples. Find the unit price. Pause the video and try this now. One thing that might have been slightly confusing in this problem is you might have thought we wanted to know how much did he pay per apple, but of course we don't know how many apples he got, only how many pounds of apples he got. Your answer should have been a price per pound. If you didn't catch that, pause the video again and try to finish the problem. Okay, so our answer is going to be $3.99 over 3 pounds. Pounds is LBS. It's going to be some number of dollars per pound. And to find out how many, we need to do division. So 3 goes into 3.99. Where does the decimal point go in our answer? Right, just up above here. So 3 goes into 3 once. Bring down the 9. 3 goes into 9 3 times. Bring down the 9 again. 3 goes into this 9 also 3 times. Nothing left. Alex pays $1.33 per pound. One more. This time I'm going to ask you to find a speed. Suppose Janice drives 228 miles in 4 hours. How fast does she drive? Pause the video and try this now. So in this story, we want to find a speed. What tells us that? Right, this phrase, how fast. And so we always want the time to be the second unit, no matter what order they're written in the problem. We'll have 228 miles in 4 hours. And that's going to be some number of miles per hour. To find out how many, we want to do division. 4 into 228. 4 goes into 2, not at all. Into 22, it goes in 5 times, because 5 times 4 is 20. Bring down the 8. 4 goes into 28 7 times. Nothing left. So we get 57 miles per hour.